think you're good to go now.
Isn't that what it's showing over there? Hey everyone, we're gonna give a few more minutes for a few more people to jump in before we start our live stream. If you have any questions for us, please drop them in the chat. We'll be happy to answer.
Also, this would be good if y'all could let us know if you can hear us and make sure we're all good to go. Kelly gave us the thumbs up.
Thanks, Kelly. All right, well, it's 2:02. I say we'll just go ahead and jump in. So, hey everyone, welcome to the WT5000 live stream. We're going to be going through some talk about power analyzers in general, how to set them up, what they are, and just talking about the WT5000. I'm Courtney, and this is...
I'm Christian. We're both application engineers, so when you guys have support cases, you guys call in, email in, we're typically the ones to answer those.
Yeah. So I guess we'll go ahead and get started. Christian, if you want to pull up the monitor. So we'll just start by giving a general overview about power analyzers and how they work. Specifically, we'll be talking about the 5000, but for most of our power analyzers, they operate based on the same theory, functionality, so that's what we'll be talking about here. So this is a block diagram. This is the one specifically for the WT5000, but it looks pretty similar for most of our available power analyzers. So essentially, how does a power analyzer work? We take a voltage input and then a current input. That voltage input goes through a voltage divider. The current goes through a shunt. And then from there, it goes through an A to D, and then an isolator, and then out. Now, there are some filters that you can apply that we might touch on a little bit later, but I mean, that's the gist of it. And how it actually calculates that power, the power formula is instantaneous voltage times instantaneous current integrated over time. And then typically the values that we see are voltage RMS and current RMS, which you can see the voltage root mean square and current root mean square. So that's the basics, what you're getting from a power analyzer. You're taking a voltage and a current, multiplying them, integrating them over time, and getting power.
I'm going to show the front of the device.
We'll go ahead and show the front of the WT5000. So, yeah, so here we just have a WT5000 set up with a dyno. So this is just what it looks like. We've got the touch screen here, buttons over here for those of you who are more familiar with some of our older power analyzers who only use buttons. So that's what that looks like. We just have some voltage, current, power displayed on the screen, and then some waveforms. And Christian, you want to talk about this a little bit?
Yeah. Ooh, let me squeeze through here. So over here where we're taking measurements from, we have a motor dyno over here. It is taking a DC source signal and going through an inverter and getting three-phase AC signals out of it. And then that is being run into our motor right here. And then the motor is hooked up to a brake, a hysteresis brake. So that is applying a brake to keep the speed constant. And then from that we can get kind of mechanical power out of it. So I think we're going to go show kind of the back of the WT5000 now, right?
Yeah. So we didn't really want to take the time to turn this whole thing around. So here's a picture of the back of the instrument. this is what it looks like. These inputs on the back right here, that's showing you the voltage inputs at the top, the red and black, like smaller banana inputs. There's voltage high and then low. And then the bottom, you can see a bunch of different types of inputs, but those are all for current. Now on the right side, you can see there's 4 BNCs, 2 sets of 4 black BNCs. Those are for motor inputs, so speed and torque. And then we just have some communication ports like GPIB is right here. We've got Ethernet, USB, an external clock and a measure start for synchronization, and then a video output and ground.
The video output, that's commonly forgot when people are using them, isn't it?
Yeah, so if you don't think this screen's big enough, you need something bigger, you can put it on a big monitor. And then here there's just the elements again. So we have 3 different types of elements for the WT5000. This one on the left, that's for 30 amp input, so it goes up to 30 amps of direct current input. And you can use these connectors that are underneath it. That connects to here, and like I said, up to 30 amps. To the right of that is a 5 amp element, so it's 5 amps direct input. And then this third one, this is the same element as both of these, but you can slide this slider down right here and it reveals this blue BNC. Now what that's used for is if you have one of these clamp-on CTs right here and it outputs a voltage, so say 1 millivolt per amp, you can put that in here, and then the power analyzer will calculate and turn that back into a current. And then this one on the far right, this is our CT current element. So what this looks like, and I'm going to turn our video off so you can see an example better at the bottom. So basically this is for a CT that outputs current. So this clamp on right here, like I said, this is a voltage output. This one, it takes a current, say 1,000 amps, and it has a turns ratio, we'll say 1,000 to 1, and that would turn that current into 1 amp. So the power analyzer is only seeing 1 amp. So this element supplies power to that CT and then reads the current directly. Many of you have probably seen a CT power supply if you have CTs hooked up, and it can kind of be a mess with a bunch of wires everywhere. This just kind of simplifies that process. And then if you slide this up, you can kind of see this BNC peeking out right here. So this would be for a probe similar to the clamp-on. So if it's the current probe that's outputting a voltage, you can put that on here.
And one of the important things we have with the covers is we can't do both the voltage and the actual current signals coming in. So the covers are there to protect you, because with older instruments we know that people try to hook up both, and the modules do not like that. So
so what you don't want to do, which you can't on the 5000, what Christian is saying is, if you plug in a current here and then to the BNC that's hidden here at the same time, it's no bueno. Yeah, we've had a few issues with people, but that was solved here.
We solved that. We proofed it from those issues with the cover here.
Yeah, and then these are just your normal voltage up here, inputs up here. So. All right.
So kind of going into what we can actually measure is here we kind of have a breakdown of what a motor setup might look like. So here we have an AC input and then AC to DC conversion. We have our inverter converting the DC into three-phase AC, and then a motor converting all that to mechanical power. So what's important about a power analyzer is that we can measure all these data points here, and we can get, importantly, in our setup that we have here, we're taking a DC voltage source and converting that through an inverter to three-phase AC. And then we're then again, getting mechanical power here at point M. So in our setup, what we have right here, we have points 2, 4, and M. We're going to turn the side camera on so we can see the motor here. So, ooh, I'll squeeze over here. So back behind here, we have point 2, which is just a DC power source. And then we got our motor point. So between the DC and the first motor, we have an inverter, so we can measure DC power, AC power. And then we have the motor here and the brake, so we can measure mechanical power there. What's kind of important to all these is that we can get, let me get this, efficiency values from them. So if we know the DC and AC power, we can calculate the efficiency across the inverter. And then again, if we know the power coming into the motor and the mechanical power coming out of the motor, we can actually determine what efficiency we have in the motor. So those are kind of the important keys to note and why a power analyzer would be so useful in a motor testing setup. Let me turn the motor off. Okay. So what do we have next?
So I think next we'll talk about the wiring, because you saw the elements on the back, but how do you actually hook those up? And so there's a few different wiring diagrams. We're not going to go through all of them, but essentially you have a single phase 2-wire input. That's the simplest one. And that's what we have hooked up to the WT5000 for the DC input. And then you have like a single phase 3-wire, which we're not going to go over too much unless anyone has a question about it. And then we have 3V3A, but just talking about one phase 2 wire. So this represents that element that we just saw. So these are those voltage inputs that were at the top, the small like red and black ones. And then these are the current inputs. So that could be the 30 amp element, that could be the 5 amp element. And so essentially you're just taking voltage high and voltage low and connecting them. It's pretty simple. So your current is connected in series and this voltage is line to line. And then the 3-phase input from the motor, we have it connected in 3V3A. So again, this is using 3 elements that are on the back. So same, again, this could be the 30 amp or 5 amp, but those are those elements I just showed pictures of. And here we've got this connected line to line. So these phases are in reference to each other, not in neutral. That's something to keep important that we have a lot of questions about. So your voltages, again, they're referenced to each other. This current is connected in series. So you can get each of these current inputs. And then this is used and it calculates power from it. So we'll show that a little bit more on the instrument, but this is kind of the theory behind how that's connected.
Yeah. So maybe just to make a quick note on the 3P3W versus like a 3P4W, which is, as Courtney kind of mentioned, is we're measuring the voltages line to line. So they're being measured with in comparison to one another. Mm-hmm. A lot of like our DC measurement, we're doing it to a neutral. So you're measuring, when there's a bit of a difference in the calculation when you're measuring to a different potential versus when you're measuring to a neutral value.
Yeah, we get questions on that a lot, and it's simple and complicated at the same time. In simple terms though, it's just, again, the voltages are referenced to each other line to line, and so you're not getting that same phase difference you would as if it were to a neutral.
So what are we up to next?
Let's switch to the instrument view. Is that one? No, we need to switch to this. Okay. So this is our software IS8000 that we have on the screen right now. This is running the exact same way, or showing the exact same screen as what's on the WT5000. So you can actually remote control the WT5000 through the software, and that's what this tab is right here. So if I pull up, let's see, this one, So it's kind of hard to see because the 5000 is small in this camera, but this screen is exactly the same as what you're seeing over there. All the buttons that I'm pressing over here are going to show up over there. Any buttons I press over there are going to show up over here.
It's just a remote control access to it. So
Yeah,
you can connect it, you can control it from a computer instead of having to be right in front of the device.
Yeah, exactly. But this just makes it a little bit easier to see for our purposes. So you've seen the elements, you've seen the front, you've seen physically what we have connected, and then a diagram of that. Here are the actual measurements that are being output. So here you can see elements 1, 2, 3, 4, 5, and 6, and the sigma. I'll talk about that in a second. These elements correspond to the pictures that I just showed in that diagram with the wiring. So element 1, element 2, element 3. And these 3 elements are what we have connected in 3v3a. This 4th element over here is the DC input. So going down the column, for element 1, we have element 1 RMS voltage, we have element 1 RMS current, power, apparent power, reactive power, power factor, phase, and then frequency. And then same thing, element 2, all the measurements that I just went over, element 3, and then 4. So this is just a all items display, so you can see all the basic measurements that most people are looking for are displayed here. And then at the bottom of the screen, it's just a waveform display of that. So you can kind of see the colors that correspond to the waveforms, but we have voltage and current 1, 2, and 4 on here. Well, 1, 2, 3, and 4, actually.
Yep. Down at the bottom, we have our DC signals, and then the first 2, we have on the top, we have our AC voltage, and then in the middle, we have our AC current.
Yeah.
So, and this display right here isn't necessarily just all the calculations that it can do. It can do plenty more. There's plenty of tables in here, but we could spend lots of time going over every single measurement that it can be made. But here are some of the important ones and ones that we typically use in a day-to-day basis, right?
Yeah. And then this column right here, this sigma A. Sigma A is calculating a sum of URMS 1, 2, and 3, currents 1, 2, and 3, voltage 1, 2, and 3, added together, divided by 3. So it's essentially an average. The same thing for the current. And then the power is calculated, as you can kind of see here on element 3. This is a negative power, which, how does that make sense? We have a positive voltage and current over here. How did we get negative power? Well, that goes back to what we were talking about with 3v3a. The voltages being line to line, so that phase difference makes this a negative power, but because of Blondel's theorem, which is something we've talked about in some of our other videos on YouTube that we can send out if anyone wants them. But you only need 2 elements in order to calculate power for a 3-phase system. So Blondel's theorem states you need 1 less element, or our elements are voltage current pairs, than the phase that you have. Yeah. So this power is actually element 1 power plus element 2 power.
Yep.
Yeah. So this sigma is really the power value that we want to look at when we are looking at 3v3a wiring. We do have what's called delta calculation, to where you can get these individual phase voltages and currents. So that's a useful feature if you ever want to see those. But for most people, we find that that's not super necessary. So, do you have anything else to say about this? We can kind of go into a little bit of the setup.
No, yeah, I was going to say setup. Maybe we can look at the some of the computations that we have. So these are all just measurements that are being taken real time. But another thing that we can do is we can do calculations upon these measurements. So maybe we should do the setup first,
Yeah,
and then we can discuss the computation part after that.
Yeah.
So right here we kind of have our setup window. The important thing is this is one of the first things you want to set when on here, because this is going to determine how it makes all its calculations, how it determines if it's measuring line to neutral, and make sure we're getting the right power calculations. So we got our wirings here. You can select between the plethora of wiring schemes that you can use, and then
and these other, so when we select 3v3a, so once you click on that, you can go and click on it. It will actually link the other elements after it. So essentially, if I set element 1 to 3v3a, it knows that you're using 3 elements, so it's going to set element 2 and 3 to 3v3a just automatically. So that way you can't really, yeah.
See, so here, as Courtney's saying, now it's just measuring power on the individual elements, so we have that. But when we tell it, hey, we're calculating power across the 3 elements, we want to link them using 3v3a, then the device automatically knows, hey, we're gonna link the next consecutive 3 elements together for this power calculation.
Yeah, it just makes it a little less confusing. If we tried to set like element 5 to 3v3a, it wouldn't be able to do it because it's like, hey, I don't have 7 elements in here. The WT5000 can actually have up to 7 elements, but the one we're using only has 6, so it automatically recognizes that. And yeah, so with our 6 element setup, we could have 2 3-phase measurements, and then if we had a 7th element, we could have a DC on there. So we'd have, like, say 3 phases in, 3 phases out, and then a DC. So we could make all of those measurements for even more efficiency.
Yeah.
You could see how efficient everything is.
There's lots of points you can attach on to
Yeah.
different systems and get lots of data. So that's kind of the wiring schemes we can set up. Below that we have our voltage and current ranges. These are important because you want to tell the device what the best or optimal area to determine its calculations from. So you can either set this, or there's an auto feature. What's nice about the auto feature is that it'll already determine, it'll search through the different voltage ranges and then determine whichever one it will be most accurate within. So then as well with the auto is if you have a transient signal, as if it goes in between ranges, it will auto adjust into the next range, which is also a unique and cool thing that it'll do. So your calculations won't become any less accurate because it's changing from a high state to a low state, or vice versa.
Yeah, my vote is always use auto. I just tell everyone, just put it in auto range, it'll make your life easier. There are a few cases where I say don't do it, but for the general population, I say just go ahead and throw it in auto range. Otherwise, you either won't get the best resolution, or say your voltage or current range is lower than it should be, you'll get an overcurrent, and then you're like, hey, why am I not getting any measurements? You know, I'm within the 5 or 30 amp limit of the element. Why am I not getting measurements? Oh, well, what's your current range, your voltage range? So, yeah.
Yeah. Most importantly, it comes down to accuracy, and you want to be the most accurate, and to be that, you got to be in the right window. You got to analyze the data in the right window.
Yeah.
So, and then as well in this current range here, you can set a ratio. If you're using some form of CT, you can set the millivolts to amp ratio for that.
Yeah, so that's if you have that BNC that I was showing on the back, and it's a voltage output current clamp, that's, yeah, like Christian said, that's where you set that ratio up. So it's pretty easy. Most of the clamps will just say whatever the ratio is on the clamp itself, and then you're like, oh, there it is, and then you just set it.
Yep. And then kind of beneath this, we have some scaling. It just allows you to add a multiplication factor to your value. So let's say you're using a voltage transformer, current transformer, you can set a multiplication factor to those values to make sure that you don't have to do any post-processing to your data. You're getting the actual numbers that you're wanting right in the instrument itself. And then below this is an important feature of the power analyzers is there's a line and frequency filters. Now, kind of, if we go back to the block diagram of the power analyzer, our signals are coming in, and they're coming in at different frequencies, and you have kind of like a spectrum of frequencies at which your power signals come in. And so sometimes you don't necessarily want to analyze the whole range. You're wanting to kind of focus in on the important parts of the signal, right? So there's frequencies at which noise can be introduced. There's a lot of things like that. So it's important to be able to implement both line and frequency filters. A line filter is at the beginning of the element, and it cuts off any signal above that from entering the DSPs, or the signal processings, whereas a frequency filter is a little bit afterwards, runs in parallel. So you don't necessarily lose those power calculations, but it goes to fine-tuning your graphs and your vector diagrams and things like that.
Yeah. Yeah, and harmonic measurements.
And yeah, your harmonic measurements.
Yeah, so frequency filter is very important for the harmonic measurements. We always recommend having that on. The line filter, we always recommend having it on, start at the highest frequency, and you'll notice the lower that you go on that line filter, the prettier your waveforms might look, which is good, but not always necessarily a good thing if you're actually cutting out a voltage or a current that is, some kind of signal in your waveform, right, that you need to see. So it could make your efficiency look really pretty, like you could have over 90% efficiency, but you're cutting out all the bad stuff that does probably actually exist. So that's one that we recommend, but just on a case-by-case basis. Especially if you have a known noise above a certain frequency, definitely put that on there.
Yep. Well, and as you can see, we have a 60 hertz motor, I believe, or around there. We have a 100 hertz frequency filter, but then we have a 1 megahertz line filter. So
yeah,
it's something to be cautious with for sure.
Yeah.
All right. So then, should we kind of discuss kind of the advanced options, some of the where's the computations we can do?
Yeah.
So here's kind of our efficiency page. So what's cool about this is, like as we were saying, we're getting all these calculations. We can measure real time the efficiencies that you're getting. So between your inverter, the efficiency of your inverter would be your DC power and your three-phase AC power. What kind of efficiency are you looking at there? What are the values we're obtaining? Again, you can do that across the motor. You have your AC power and your mechanical power. And then importantly, which you want to know for your whole system, you can look at what's coming in and what's coming out and the efficiency of the whole system combined. So in this page, it's kind of where you can set those values for where your efficiency is. And then if we go back to the display, let's see, where do we have a window for that? Let me see.
You could change it to a numeric.
I'll set that up. We can get...
See, Christian's going old school. He wants to use the buttons.
Yeah, it's my favorite. So here we have the efficiency of the inverter, and then we can get the efficiency of the motor. Ooh, that's some low efficiency there. And then we can get the where did it go? Efficiency of the whole thing. So, kind of gives us some perspective and some good analysis points, especially when it comes to analyzing something like a motor.
Yeah, and all of those are adjustable. These are just the numeric symbols that represent efficiency, but on that calculation page, like Christian showed, these can all be changed. So just makes it a little easier, and you can even add them together. These are again numeric items that you can select. We have, I don't know, probably over 1,000 measurements that you could do, especially if you're counting each one for the elements.
Yeah.
So
I think there's 256 per element. And then you can have, from there, we have seven elements. So
it can get to be a lot, but the important thing is getting what you need. So in finding that, I mean, we can show, Christian kind of just showed it, but if you go into here, into display, the items, they're separated by function. So you have your voltage. So for example, even voltage, it's simple, but it's not quite that simple. Sorry, my fingers are not wanting to work. But even for voltage, we have RMS voltage, which we talked about. That's root mean square. We have mean voltage, which is just a different way of calculating it. We have DC voltage. So there's a lot of different options here just within, just within the voltage measurement. You can actually scroll down here, and that's so that it opens up even more categories to go through, and then there's the motor inputs too, which we kind of touched on a little bit, mechanical efficiency. So this is your speed and torque, but this is just to show there's a lot of different measurements you can make. You can always ask us, Colin, to support and say, hey, I need to make XYZ measurement. How do I do that? How do I set that up?
Yep. So yeah, it can do a lot. We can capture lots of data. There's not a lot that we can't capture with our instruments. So.
Yeah. Yep.
Should we show kind of a DAC setup and then kind of see where we are with questions from there?
Yeah, and please, anyone, feel free to stop us, ask us questions. It doesn't even have to be related to what we're talking about necessarily. Maybe keep it on power analyzers, maybe not like football, but.
So here we kind of have a DAC monitor going right here. So what we can do is, this is our IS8000 software that Courtney alluded to earlier, but in it we can both control the devices, but also pull data from it. What's unique is you can record your data in a DAC style straight from your power analyzer. So if you want to look at your data over a period of time, you don't just have to look at instantaneous values or storing options here. There's also storing options through the computer and through these programs. And what's unique is you can also tie some of our other instruments like a DL950 into it and then synchronize them so that we have you can pull lots of data together through this. Mm-hmm. So let me see if I can get a control. So that's fine. Right now we're just pulling RMS data points for the three-phase signals and the DC signal. So they're going to be kind of flat. They're kind of boring. I probably should have picked some better looking ones, but it's cool that we can have the data here, but also have it recording somewhere else and look at it over periods of time.
Yeah. Yeah, and that records straight to your PC, so you don't have to worry about, how am I going to transfer the data from the power analyzer to the computer to then be able to read it. And you can actually open this file once it's done recording. You can open it back up in IS8000 for analysis, or you could convert it to like a CSV file to open up in Excel and look at the data there. You can also store the data on the 5000 if you want to do, just store it to a USB, or you can use FTP to transfer the data from the 5000 to the computer without the software. So there's a lot of different options there. You can set it up to store for a while. I think that might be, so we've got a store function that you can set up manually where you just hit a start button, hit a stop button, and it records whatever data that you select in here. So all those items that are available that we went through on the numeric list, they're all in here. You can select them, and those will record. You can set it to record to a CSV file. So there's a lot of ways to get data. I mean, it's nice to look at data, but it's important to be able to collect it and actually use it. So.
Mm-hmm. Let's see if we, I think that's kind of towards the end of what we had to kind of show off. Is there anything else you'd like to do, or kind of open it up to see if we have any questions or anything of the sorts?
Yeah, I mean, we can definitely open it up for questions if anyone has anything.
Pull this up. Here we want this. Ooh, okay.
And if you don't have questions you want to post in the chat, you can see our website flashing at the bottom and our contact information for our support email. So We have chat on our website where you can get on chat with one of our chat agents and ask questions. You can email us, and a case will be made. One of us or one of our other application engineers will help you out. And we also have a phone call. I know some people love getting on the phone and, solve some problems a lot faster sometimes than just going back and forth on email. So yeah, there's lots of ways to contact us, and we'd love to answer your power analyzer questions.
Yep. Is there, so as an application engineering, you're kind of alluding to it, but is there anything that you've been working on with the power analyzer recently that you've thought was unique, interesting to note?
That's a good question. I think we just got this dyno set up. That was actually more Christian. That was pretty much all Christian, actually. But it's been really cool to get a bunch of these live measurements so we can help answer questions about, efficiency calculations, about motor and speed, speed and torque and efficiency, and all of that. Just makes it a little bit easier. We're also currently, both of us are working on a training module for the WT5000, and I've been finding a few little hidden buttons where I was like, oh, I didn't know that it existed. Honestly, like, the basic principles of it are so easy. Again, you got a voltage and a current input, multiply them together, you got power. That's simple, but there's so much that you can do with it, and as I'm going through all the menus and figuring everything out, it's just opened my eyes to, like, even more that it can do. So yeah.
And now, as Courtney's kind of alluded to, I've used alluded a lot. What's a better word than alluded? But I've been working on the dyno setup we have over here, and it's been a cool experience. It's opened my eyes to what, like, kind of the EV markets are and what they're doing, and just a little taste in a miniature setting has been cool. That's one of the things I've been most interested in outside of work, so kind of being able to bring that into work has been cool. There's understanding how kind of an inverter works and how it controls a motor and gets vehicles moving. It's an interesting process in how they're being controlled, and working towards understanding those values and obtaining those values. It's been a very enjoyable project that I've been able to do. So it's still going. We're hoping to get a whole bunch of other values and create packages so that we can show off our motor analyzing skills or tools. But it's been a fun project.
Yeah. Let's see if we got any questions.
Ooh, Fern has a question. He asks, let me see if I can pull this up. Ooh. What kind of triggers can I set up with the power analyzer?
So, I guess, do you mean like triggering on the power analyzer? So it's not necessarily what the power analyzer is best at. So it's not really a triggerable instrument. There are some options in there, but they're very simple triggers, like I can't remember where the menu is. I just looked at it the other day, but you can set up some triggers on here that it'll essentially, like, if a voltage hits a certain level, it'll trigger and do a few things that you want it to. But really, for triggering, that's more of our scope quarters or oscilloscopes. They have, like, that's a 950. I think you can see it back here. Well, this is our oscilloscope, 950. We actually have another 950 over there. Those are triggerable instruments. They have advanced triggers that you can set up. And like we were kind of talking about earlier, if you really wanted to trigger off of power data, you can do that really well with the 950, and you can synchronize this waveform data with the WT5000, and so you can get those triggered waveforms as well as your accurate power data.
Yeah. Well, one of the things I guess maybe we should note is that the power analyzer isn't necessarily a triggering device like oscilloscopes are. It's an averaging device. So it's taking instantaneous data and then averaging them out over a period of time we call them update rates, and then it's spitting out an update of the new calculated data. So the kind of instantaneous data you're looking at with an oscilloscope isn't necessarily what we're trying to get from a power analyzer.
Yeah. Now, to add maybe a little bit of confusion to that, or maybe a little clarity, we do actually have a PX8000 set up right here, which is our power scope. It actually does trigger, it does use some of those enhanced triggers that the scope quarter or an oscilloscope can use, but it is accurate power data. The problem with the 950 is that you're not getting as much accuracy as you are with the WT5000 because they serve two different purposes. But with the PX8000, you can actually, it's kind of an in-between. It's got accurate power data and triggerable. And then we got, and then can you use an external trigger? You can use an external trigger. That's one of the inputs on the back, and that can help synchronize your data or do like a measure start. It's just a BNC input. I don't know, I can't remember the exact specifications, but they're in the manual of what kind of trigger that can be. But
Right.
yeah.
And then we have a question. Is there a way to connect a resolver instead of an encoder as a motor speed input? You want to take
That's
this?
you.
I've
I've answered two in a row.
So
I'll let Christian handle it.
in the WT5000 itself, the inputs that we allow are an ABZ encoder or just a speed device, but not a resolver. We take resolver inputs into like our scope quarter. It has a specific resolver math calculation, but the WT5000 does not have a resolver analyzing component to it.
Yeah. So that's again something that if you needed both of those components, like the accurate voltage, current, power, and then the resolver input, you could combine these in the IS8000 software and look at that all at the same time.
Yep.
Yeah.
Then we're getting good jobs over here. Justin's out here selling us good jobs.
Thank
Thank
Justin.
you, Justin. Let's see. Can the WT5000 be used to calculate inverter switching losses? So inverter switching losses, that's a very high frequency analysis. So you'd have to sample at a higher rate than what the power analyzer can do to detect inverter switching loss. So we have an oscilloscope that the functions, there's a specific function to analyze these switching losses, but that is sampling at, what is this one, like 500 megahertz?
Yeah.
Which is significantly faster than what the power analyzer is kind of set up to do. So the power analyzer, the WT5000, can't do inverter switching loss, but the our oscilloscope, the DLM 3000 and 5000s can. So, pop this down. You have anything to note on that? I don't know.
Yeah. I mean, if anyone has any questions on any of our instruments, feel free to drop them in the chat, or we can wrap it up. And like I said, you can get in contact with us over the website or the email or phone number. We have a full suite of instruments for power measurement and more: scope quarters, oscilloscopes, power analyzers. So anything like that. Oh, we got one more question. Let's see. With the WT5000, can I stream data to IS8000 at 10 megasamples per second? So no. You can stream it pretty fast, but the thing about the power analyzer is that it samples at the 10 megasamples per second that you're talking about here, but it's using those samples to then do calculations, and that's how it's calculating power and calculating voltage RMS and current RMS. So it's taking that instantaneous voltage and that instantaneous current at 10 megasamples per second, and then using those to do calculations for RMS, voltage and current, and then the power. So
yeah,
you can sample it pretty fast. You can sample it 2 megasamples per second using the data streaming option. So you can still get pretty fast speeds.
Yeah,
but
I was just about to say that.
Yeah.
10 megasamples per second, which is what it's trying to measure instantaneously, can't be brought over into IS8000, but it can still bring over 2 megasamples per second into the,
Yeah.
it's 2 megasamples per second.
2 megasamples per second for
You
two.
can unhide that. There we go.
Oh, okay. Oops.
It's hidden.
2 megasamples per second for 2 channels. So if I wanted like just 2 voltages or 2 currents or voltage current, you can sample at the 2 megasamples per second. You can still sample pretty fast with more measurements, but the speed decreases as the channels increase. Yeah.
So it's 2 megasamples per second for one element, let's say, because you would be pulling both voltage and current from one element most likely. So.
Yeah.
Fern has another question. Can Mac users install IS8000?
Oh, that's a good question. I think so.
Yeah, I've used it on my Mac. Now it's an older Mac. It's not the M1 chip Mac, but I've used IS8000 on it before. So that's a good question. I want to see if there's any problems with the new Apple chips, but I know that the older Intel chipped ones they work on them. So.
Oh, interesting.
Yeah.
We'll give it another minute or so for any more questions. Maybe it's not a question. Maybe it's just you want us to see us touch some buttons in here.
Let's see. Fern asks, what happens to data for an integration when there's a power outage? What kind of power outage?
So actually, this is one of those things I discovered while I was working on a training module for everyone. Let me get to the menu. So, in the integration menu, there is this resume action feature. So you have a stop, a start, and an error. Essentially, that's when a power outage happens, which we know they can happen frequently. You don't want to lose all your data. You can set start, stop, or error, and that's going to set how the instrument turns back on, what integration settings you have. So with start, to be honest, I'd have to read it again to remember it, because I just discovered that this was a thing that you could even choose from. With start, I believe it pauses where you left off, and then once the power analyzer comes back on, it restarts. Stop, once it turns back on, that integration data will say paused, and then error, I think that the data stays paused, but it displays an error and it lets you know that there was a power outage. But I'll have to look back into the manual to make sure I'm right on all of those. But you can switch between those 3 things, and it determines what happens when there's a power outage.
That's cool. I didn't know that.
Yeah, it's one of those little hidden gems. I don't think that was an option on some of our older power analyzers. I think I want to say it did start, but now it's something that you can select.
It's pretty cool.
Yeah, and with the integration, when you're setting up integration, which I guess we can explain integration a little bit. Essentially, if you want to calculate watt hours, to say you're doing like standby power or something like that, and you want to calculate. Sorry, we're getting some more questions. And you want to calculate watt hours over time. That's what integration is doing. So you can press start for that, and it'll start counting up voltage, current, power.
So that's kind of like a time base for your calculations.
Yeah, exactly. But there's in the store mode that I was talking about earlier, there's an integration sync. So when you press start on integration, it will start storing data at the same time, and then stop, it stops it. So that could affect your stored data depending on what resume action you choose in integration. Can I synchronize multiple power analyzers? Yeah, there's a few ways to do that. There's that measure start that I was talking about. So you could put a BNC from one to the other, essentially, and you could synchronize them that way. You could also synchronize them in the software. IS8000, you can connect 4 power analyzers.
Sure.
I believe it's up to 4. the power analyzers, and they could all be synchronized at the same time.
And then,
he said in a master sub configuration. So yeah, that's what I was talking about the first time with that BNC, that measure start on the back.
yeah. So it would be either through that on the BNC port for the master sub, or if you wanted, you could synchronize them all with, you could do IEEE, right, for them. So you could synchronize them with the IEEE 1588 standard using IS8000.
Yeah, if you need like really precise time synchronization. Fern is just bringing the questions today. Are the channels on the watt meters isolated? Yes.
Yeah.
So watt meters is elements, that they're the same thing. We use those terms interchangeably, but yeah, they're isolated. You'd want them to be especially when you're inputting high voltage and current. So yeah.
The voltage inputs can take
up to about 1,000 volts.
1,000 volts, and then depending on the current modules, you can have 5 amps or 30 amps, or obviously more because there's some high current signals, but you'd want to use a current transformer with those.
Yeah. Yep. Cool.
We got some good questions. Fern hit us with some good questions.
Fern has just been waiting to ask some power analyzer questions, I can tell.
Mm-hmm. Well, this is a good opportunity, and if there's any more that come up, we can be reached as you said we can have a chat on our website, or you can call or email, and we'll create kind of a support case for you and figure out the best way to support your needs.
Yeah.
Okay.
Is it only compatible with IS8000? So in terms of software, no, there's also WT Viewer E, and then there's a free version of WT Viewer E called WT Viewer E Free.
Love the naming, right?
Right. It's a bit of a mouthful, but it's a great software. So especially if you're someone who already has that software, because it was used with some of our older equipment, you can use the WT5000 with that software. It does similar things to IS8000, like you can remote control. It doesn't bring up this GUI like this, but you can change all the settings on there, and then you can also collect data straight to CSV on there. And you can also, we have Skippy commands that you can use if you want to program the instrument that way.
SCPI, right?
Yes, yeah. SCPI. So yeah, there's a few options. Anything I missed? So that would be like if you want to use it with Python or LabVIEW or C++, something like that.
There's the web server, so you can interact with it straight through the Ethernet port on it. So you can log on to the IP address, and there's a bit of a web server where you can, the remote control is one of the important thing through the web server.
Yeah, you can remote control. It doesn't really do the same data output that you can't output data to a CSV, but you can pull data from the 5000 onto your computer using the web server. So that's one option.
And so the WT Viewer, one of the reasons it's compatible with a few softwares is the power analyzer itself is 5-6 years old, almost. It's a little bit older.
No, it's probably 3 years.
3 years? Okay, sure. But IS8000 is a bit of a newer software.
Yes.
So that's kind of the new standard for what our softwares are, and building up on those. So it's cross-compatible with a few, but as we kind of move forward, power analyzers will hopefully be able to just use the one IS8000 to bring all the instruments into it.
Yeah, so the thing about WT Viewer is that it's only for power analyzers, whereas IS8000 you can use with the scope quarter, the oscilloscope, and synchronize all your data using one software instead of having multiple softwares for multiple instruments.
Yep.
So on three-phase applications, can I use one 5-amp element and two current sensor elements? Two current sensor modules. So when you're doing a three-phase, so say you're doing 3V3A and you're using 3 elements, all those elements have to be the same. So you'd have to have either 3 5-amp or 3 current sensor or 3 30-amp Is there a vector diagram option? Yes, this is actually something we didn't show. Thanks, Kelly. That's actually a really good thing to show.
Pull it up.
There goes Christian again with the buttons.
Uh-huh.
Okay.
And then we gotta share it with them.
Oh, right. You go for it.
Yeah. I got it. So
Okay.
here's the 2. Let's bring this down to. Ooh, no. I'm pressing the wrong buttons.
Go to form.
Yeah. So
There we go. So this is a vector diagram. We can zoom in a little bit. So this is a vector diagram. It shows the phase relationship between the voltages and then the currents. This triangle that you see here, those are the voltages, and then the upside down Y are the current legs. This is great not only for showing the phase relationships, but when you're wired in 3V3A especially, it can tell you essentially, do I have it wired right or not? Which sometimes when you're dealing with a lot of wires and maybe it's messy back there, it can be hard to tell if you have it wired correctly or not. This is one simple way to do that. It's actually something that happens a lot is people will say, hey, I'm not getting the right power measurements. I don't know what's happening. Like, how is it being calculated? What's the situation? And most of the time, the first thing we ask is, hey, can I see a vector diagram?
Yep.
And then we know, based on that vector diagram, if it's wired correctly. And if it's not, as soon as someone wires it right, that most of the time solves I'd say 99% of the time solves the problem. So.
Yep.
Yeah.
It's key to kind of understanding the signals that are coming in, and especially in a 3V3A setup, understanding how they are in relation with each other. So
Yeah.
It's a very useful tool. It's one of those things that kind of coming out of school I didn't really know about, but learning more about power and the 3V3A setups that can be used, it's very important.
Yeah, definitely.
And here, let's bring it back to here. Fern asks, can we set up a 3-phase configuration that includes a neutral or a floating neutral?
Yes,
Yeah.
so that's the 3-phase.
So we'll switch back. We can go to a 3-phase 4-wire setup.
That's what this is.
So there'd be 3 high currents and then a 4th neutral that you could measure them with respect to.
Yes.
So.
Yep. So essentially, you would, instead of connecting the voltages to each other, so like phase 1 voltage to phase 2 voltage, it would be phase 1 voltage to neutral.
Yep.
And yes, that's available here. We don't have anything with a neutral, so we can't make those measurements here, but anyone that does, I mean, yeah, I can still set it to this. It's just going to do the calculations, like it messes up the vector diagram because it's expecting you to see something else. But it'll still do the calculations. You can set it to that, but this would be for if you have that neutral available.
Yep.
So, cool.
Let's see. We can bring it back to us. Look at our beautiful faces, right?
Okay. I think that might be all the questions. Maybe we'll give it another minute just in case anyone has any last minute questions. But, again, feel free to contact us at this email, yca-support@yokogawa.com, or go on our website. We have a lot of useful resources on there. We have, our YouTube channel that we're using right now. We produce videos all the time. And oh yeah, you can actually bring it up. So there's a lot of great resources there. We do a lot of either commonly asked questions on here or common applications that we see. So there's a lot of available videos that are great resources. I send out videos all the time if it's something that helps show someone something. it makes it a little bit easier. And there's plenty on the WT5000 for sure. Or our other power. WT Viewer E.
Look at a young Courtney over here.
My most popular video. So yeah, there's a lot of great resources here. And then on our website, we have white papers, we have app notes, we have FAQs. So a lot of information out there. And but if you don't really feel like searching through all of it, we are always here as a resource.
Yep.
So.
And then we got our website here. It also has a plethora of good information. Our industry page is actually cool because you can see a lot of the graphics that we use now and in this live stream, but also in certain presentations we do. It's good. You can kind of see all this, and there's good information here for you to kind of see what we can do for your specific application.
Yep.
So we got lots of information between the application engineers, the website, our YouTube videos. There's lots we can do.
Are we on Twitter? I believe we are, actually. I don't know if it's an active Twitter account, though.
That'd be a question for Kelly.
I'll have someone get back to you on that.
I know we got LinkedIn and we got YouTube, so I don't know about Twitter.
We do have LinkedIn, where we put out a lot of posts on there for things like this live stream, or just good information is on there.
Yep.
Yep.
All right. Well, cool. I don't necessarily know if we got anything else to cover. I think we covered a lot.
Yeah.
Got some good questions in, hopefully. So if you guys have any more questions, like Courtney said, please reach out to us. We'd love to get in contact with you, answer whatever you got.
All right. Well, thank you everyone for joining. Have a great rest of your day.